Good afternoon, Year 10. This is lesson 4 in your booklet. It's on changes of state. So this is your starter. This isn't in your booklet, so if you'd like to just get yourself a spare piece of paper and have a go at answering these 3 questions, pause the video here and then press play again when you've finished. Okay, so here are your answers. A was a gas, B was a liquid, and C was a solid. You can tell by the way that the particles are arranged. In question 2, which of the following statements are true about the particles in a gas compared to the particles in a liquid? In a gas, the particles have more kinetic energy and they move faster. A common misconception is that the particles get bigger as we move from a gas to a liquid to a solid. The particles don't change size, just the forces between them are getting weaker and the particles are moving further apart from each other. The reason that solids have a fixed shape is that the particles are packed closely together and held in place by strong forces. That means they can't move. So today we're going to be talking about what melting point and boiling point are and how we can find those points from a graph. We'll also explain the difference between boiling and evaporation. When a substance is heated or cooled, it can change state. And that happens because the heat energy supplied is transferred to the particles. That makes them move more and overcomes the forces that are holding them together. You can see in the diagram below the names for the changes of state. So a solid turning into a liquid is melting, a liquid turning into a gas is boiling, a gas turning into a liquid is condensing or condensation, and then liquid turning into a solid is freezing or solidifying. So we're going to look on this slide at the difference between boiling and evaporation. Both of these terms are describing the state change from a liquid to a gas. But evaporation will happen at any temperature. Some of the particles in a liquid will have enough energy to escape the surface of the liquid and turn into a gas. So if you leave a glass of water out on the windowsill for a week, some of the water will have evaporated by the time you come back. The water hasn't boiled, but some of the liquid has turned into a gas. Boiling only happens at the substance's boiling point. So when we talk about the change of state happening, changes of state are physical changes. We're not changing the chemical makeup of the substances, we're just changing how those particles are arranged, whether the forces between them are strong or whether the forces between them are weak. Mass will always be conserved, which means it stays the same in these state changes. So for example, if I had 200 grams of ice cubes, which is a solid, and I melt them, I'll have 200 grams of liquid water. The mass of the substance hasn't changed, it's just the state that it's in. So we can gather data from an experiment to show what's happening when something melts or boils. This data in the graph has come from an experiment where we've taken a beaker of a substance as a solid and we've heated it over a period of time. And every 10 seconds or so we've taken the temperature and recorded that in a table. When we plot that data on a graph, we end up with a shape that looks like this. To start with, the temperature increases until 0 degrees and we have a flat section on the graph. The reason for this flat section is that the heat energy that's being supplied is now being used to break the forces that are holding the particles together in the solid, not to raise their temperature. Once the substance is melted, the temperature does start to rise again, and you can see it rises until 100 degrees, where the graph turns flat again. Where the graph is flat and labelled boiling, the substance is turning from a liquid into a gas. Again, the heat energy being supplied at this point is being used to break apart the forces between the particles. So the temperature of the substance does not rise while it is boiling. Once the substance is boiled, the temperature of the gas begins to rise again. The energy that's transferred to a substance when it's changing state, so in these flat sections on the graph labelled melting and boiling, is called latent heat. And we're going to look at latent heat in a bit more detail in a few lessons' time. This graph can also tell us information about the melting point and the boiling point of this substance. If we read across to the y-axis from our flat section, we can see that this substance melts at 0 degrees C and it boils at 100 degrees C.